I will offer to you for the y coordinate. Yes, Lincoln.
Because we know that line's always 0.
You know that that line has a y value of 0, right? Great. What are the coordinates of the red dot? Oh, negative x 0. It's almost like you guys are starting to understand math. What are the coordinates of the blue dot? X 0. What are the coordinates of the green dot? X 0. Now, something has now happened 4 times in a math class. What does that mean for the other infinite amounts of times that could happen? If it's happened 4 times, how many times will it happen? Every single time. If there is a dot on this line, what are its coordinates? X something 0. Agreed? Does everybody understand that? I know I am sounding a little bit aggressive because it's the second time today I've taught this lesson, and it's the second time I lie. It's the 250,000th time that kids have told me they get it, and then 2 seconds later, what? So I'm sounding a little bit aggressive because, as always, I get a little frustrated with this lesson. What does this mean? A dot on that line is always either negative x comma 0 or x comma 0. Do you all understand that? Really? Great. Now, what would the coordinates of the next 4 dots I put on here be? Don't say it out loud while I'm making the dots. Just think about it. Is everybody thinking? Good. Would anybody like to offer me the coordinates of this black dot? Yes, Liam. 0y. Would anyone like to offer me the coordinates of the red dot? Yes, Lincoln.
0y.
0y. Would anybody like to offer me the coordinates of the blue dot? Yes, Corey. 0 negative y. And would anybody like to offer me the coordinates of the green dot? Yes, Louis. 0 negative y. Oh, I did that in gray. That should have been green. Silly Myers. Everybody cool? Now, each of those points now is on a line. That line crosses each axis. Each of those points is now what we call an intercept. Which of those points would be the x-intercept? x0. They are the x-intercepts. Now I would recommend starting to draw, because we're going to be doing some writing in a minute, which means the y-intercepts are these guys that are highlighted in yellow. I'm going to let you draw that for a minute and let you think about it for a minute. In your own words, now that we have talked about it and you have all have told me you understand it, in your own words, write a definition for both of those things. That is the last thing you are going to do before I start talking again. Go. I want you to write your own, because me writing them has not been working. So you can all come up with your own definition for what those things are. Go. I am going to write mine in dusty rows. Does everybody have something similar to the two sentences which I have written? That's fine if you waited and copied mine down. I would rather you didn't, but that is fine.
No, if that makes sense to me.
Great. Should not a sentence you wrote also have made sense to you since you wrote it?
Yeah.
Okay.
Okay.
Is everybody good? All right. Now we are going to apply this to math. Here, I have a function, correct? If I were to graph that function on this graph, I would need some x's and y's, wouldn't I? Where do I find those x's and y's? I input the x's and I output the y's. Agreed? Okay. But in this instance, I am asking you to use the intercepts. Does our method change? Of course not. If I just wanted some points for this, I would put in some x's and some y's, wouldn't I? I would put in some x's, they would go into the function, and I would get some y's, and I could then put the dots on the graph, yes? Everyone agrees? But we are only going to use intercepts now, which means I am only allowed to use 2 points. What is the coordinates of each intercept? What is the coordinates of an x-intercept? 0 for an x-intercept? You just wrote it literally 2 seconds ago. What are the coordinates for an x-intercept? x0. x0. What are the coordinates for a y-intercept? 0y. Now, take these inputs and outputs and put them in to that function. What do I have here? An input or an output? I have an output because the f of x is 0. What is that? That is the f of x, isn't it? And it tells me right here that my f of x is 0. So what will I write there? 0 equals 2. What's my x? It's still an x. Plus 3, correct? How do I turn that x into a number? I use algebra. Now, This is where I find out that half of my class still cannot do algebra. This is not something I can fix for you. You have had 11 years of learning algebra. Yes, you have. Your very first math lesson in kindergarten was algebra. Just your teacher didn't use X's and Y's. She left things blank. And she counted apples instead of numbers. You have been doing algebra every day you have been doing math since the first day. At some point, you must learn how to do it. I have shown you a million times this year, and I will continue to do so. But you had better learn it soon, because you have at least one more year of math in front of you. I need X by itself. So I'm going to remove that 3. Now I have negative 3 equals 2x. How do I get rid of 2 times x? I divide by 2. And now negative 3 halves equals x. Now we come to the most complicated thing in this entire unit. X equals negative 3 halves. What letter is that? So what number goes there? Negative 3 halves. It is negative 1 and 1/2 because negative 3 halves is negative 1 and 1/2. This, for some reason, is Greek to math students. Even though this says x equals negative 3 halves, and that's an x, they have trouble going from there to there. Are you part of that group?
No.
If you are, you must struggle mightily to get out of that group and understand that if something equals x, then any x is that thing. Do you all understand that? Spectacular. What if I said x equaled 72? What number would go there? 72. What if I said x equaled 3,999,278,342?
You would write whatever you said.
Then that number would go there. Do you understand? Good. Now, do the exact same thing, except now I have f of x equals 2x plus 3. But now, what's x? 0. So I need the f of 0. X is now 0, so what do I write? 2 times what? 0 plus 3. What is that? 3. So my f of x equals 3. If my f of x equals 3, and my f of x also equals y, then what do we know about y and 3? That y equals 3. What letter do you see there? Y. So what do I write there? 3. Now, do you see an x coordinate and a y intercept coordinate? So where do we put them? On the graph. Why is this a difficult one to put on the graph? Because I got a fraction. Who's in charge of this graph? You are. Does this have to be 1, 2, 3, 4? No. What can it be? Any dang thing you want. So if we use these as halves, this point right here is now 1. Agreed? So what would this point right here be? Negative 1. What would this point right here be? Negative 2. What would this point right between them be? Negative 1.5. And right there, I would put my first dot, because that is my x-intercept. Now, I also need a y-intercept. Can I keep the same scale on the y-axis right now? What? About what? Rice? Yes. Go. Can I keep the same scale there?
Yes.
Why?
Because
There's enough space on the graph to keep that same scale. What if there wasn't? No, you would just change the scale again. Do you understand? Since it fits, and I only need to go up to 3, 1, 2, 3. It fits. So I put my dot there. What do I get to do with those two lines? Connect them. How far will that line go? To infinity. In which direction? Both. Which means what is my domain and range of every single straight line? If it's diagonal, my domain is all real numbers, and my range is all real numbers. Do you understand? Are any of you even the tiniest bit lying just because you're kids and you like to lie? Good. Turn the page over and do exactly what I just did with a new function. I'm going to pause the recording. I'm going to work with these values in blue. Where does the 0 go? Where the gx is, this whole side. 1/2 x minus 2. How do I get x by itself? I add 2 to both sides. 2 equals 1/2 x. How do I get rid of this denominator? I multiply both sides by 2. 4 equals 1x, which is just x. Where now can I write that? Anywhere I see an x. Do I see an x somewhere on my page? Yes, right there. 4. So now I get my first point on the graph. 4, 1, 2, 3, 4, 0. Everybody good? Why, and I did this on purpose because this is what most of you are going to do, why was this an error to put this on the graph right now?
in case we need to do spacing differently.
What if I need to do the scale differently? Everybody understand? So that step I would wait on. Now over to here. Where can I put that 0? Where an x is. 1/2 times 0 minus 2. And what would go here? The y. What is 1/2 times 0? What is 0 minus 2? Y equals -2. So what can I write everywhere I see a y? -2. Now, do I need to worry about scale? No, so I can go ahead and put them on the graph. 1, 2, 3, 4, and 1, 2. And what do I get to do with those two dots? Connect them. Because, of course, every dot on that line will work in this equation. Is everybody good with intercepts. Now, let's pretend for 1 minute that we're going to do this differently. Don't write this down. I just want to see if you really understand it, okay? All right. Everybody good? F of x equals x plus 3 and x minus 3. Okay, don't write this down, just look. Can I use the same method? Yes or no? Okay. 0y and x0. Excellent. Everyone agrees? All right. What can I put in for x if I'm going to do that one? 0. Everyone agree? So that would be, and I'll do that one in blue, f of 0 equals 0 plus 3, 0 minus 3. Correct? What is 0 plus 3? 3. What is 0 minus 3? 0 minus 3 is 0. What is 3 times negative 3? Negative 9. So what does y equal? Negative 9. Everybody cool? All right. Now, in this one, I have 0 equals x plus 3 and x minus 3, correct? If I want to solve that, I need this factor, right? And this factor to multiply together to make 0, correct? So if you're going to multiply things to make 0, then what does that or that have to equal? 0. If that equals 0, then whatever this is, it's going to be 0 at the end, isn't it? And if that equals 0, then whatever this is going to be 0 at the end, correct? So I need right now either x plus 3 to equal 0 or x minus 3 to equal 0, correct? Do the math. Minus 3. So x could be minus 3 or x could be positive 3. Does everyone agree? If x is 3, 3 plus 3 is 6, but 3 minus 3 is 0. 6 times 0 would be 0, so it would work. Everyone with me? This is grade 11 stuff. I'm just showing you to prove that what you learn in grade 10 will work with all lines on every graph. What about this one? Negative 3. Negative 3 plus 3 is 0. Negative 3 minus 3 is negative 6, but negative 6 times 0 is 0. So these both work, don't they? Which means x can be both of these things. So what can I write here? Negative 3 or positive 3. So I put negative 3, 1, 2, 3. Positive 3, 1, 2, 1, 2, 3. And 1, 2, 3, 4, 5, 6, 7. Damn it, 8, 9. And that is how you graph one of those parabolas. Y-intercept right there at 0, negative 9. X-intercepts, there's 2 of them. Now, what if I was graphing? Luckily, Bryce put a bunch of lines on the back of our room, right?
Bryce's graph is
What if I graphed the sine curve, which looks like this?
I don't know, man.
How many x-intercepts?
3.
3. And what do you know they all are? X, comma 0. How many y-intercepts? 1. And what do you know it is? 0, comma y. No matter what we graph, it follows these rules. Everybody cool? You'll learn how to graph these later. The point I'm trying to make is this skill, doing it with straight lines, is the exact same as using curves. Is everybody good? Sweet. Now let's move on to new stuff. Look closely at that and think about the two functions we just did. We did f of x, 2x plus 3, and we did g of x to equal 1/2 x minus 2. Can you see any similarities between what is highlighted in blue and the two functions that we have already worked with? What are some similarities? Corey, give me one.
They have similar operations going on?
They have the exact same operations going on, don't they? Right? There's something multiplies by x, and then we add something to that. Everyone agree? Cool. Anybody else see something similar? There's x's and y's. Here we have x's and y's because this is our output. When we're not graphing, this is f of x. But once we go to a graph, it becomes what? Y's. Everybody cool? All right. Now, this is called slope-intercept form. It is called slope-intercept form because it is going to tell us two pieces of information. It is going to tell us a slope, which we already know from our previous unit is the rate of change. And it is going to tell us the intercept. Now, which intercept will it tell us? We do not know, but let's look. In the first one, there's two intercepts, correct? -3 and -3/2 and +3. Which one is in the function? Everyone see? Look at the next one. There's the y-intercept. Is it in the function? Where? -2. So what then, using your brain, what does B tell us? The y-intercept. If it's plus B, it's a positive intercept. If it's minus B, it's a negative intercept. Would it matter if it was a fraction? No, we would just go to y 7/8 or y -3/4. Everybody understand? Great. Now, next, slope. You know slope is the rate of change from the last unit, yes? What was the rate of change that we spent a lot of time working with? We spent a lot of time working with speed, didn't we? And speed, you don't need to write this down because you already know it. Speed is kilometers divided by hours, correct? Or meters divided by seconds, or meters by minutes, or whatever, right? It's the dv, distance, divided by the IV, isn't it? Right? So watch. How far did I go on the dv to get from this point to this point? How far was that? 3. So my dv was 3. How far was that? 2. Correct? So my slope, guys, how far was this? 3/2. So this was 3 divided by 3/2. In numbers, right? How far was it in squares? How far up did we go? You just have to count. 6. How far that way did we go? 3. 6 divided by 3. What is 3 divided by 3/2? or 6 divided by 3, because they're the exact same, aren't they? It's 2. What do you see right there? 2. Go to this one. How far up did I go? 2. How far that way? 4. 2 over 4 is 1/2. What do you see right there? 1/2. So what does the m give us? Not if it was distance and time, it would give us speed. But if it's not distance and time, it gives us our slope, which is our rate of change. Everybody cool? So just by looking at this, we're able to graph it. No more tables of values. This tells us how to do it, and I'm about to teach you, but before we do that, we have to talk about these lines. Everybody put an A there, a B there, and draw coordinates like that. Everybody cool? Everybody good? All right. If I wish to go from A to B, but I'm not allowed, I can only move like an Etch-a-Sketch, up and down and left and right. How will I get from A to B? I will go either up and right, or what? Down, left. Agreed? Everybody cool? All right. On a graph, when I go up, math only has 2 directions. What direction is that? Positive. What direction is right? Positive. So this line must have a slope, because slope is always dv over iv. What was my change here? Was it positive or negative? I went up, so it was positive. This way was right, so it was positive. If I divide a positive number by a positive number, what do I get? A positive number. So this has a positive slope. But what about over here? What direction did I go? Down, which is what? Negative. What direction did I go this way? Left, which is what? Negative. So this side is a negative divided by a negative. What do I get? Positive. Still positive. Doesn't matter. Just matters which way I decide to start. Everybody cool? So what then is happening over here between C and D? How do I get from C to D? Right, down. I would go right and down. Now remember, we have to put the dv in the numerator spot. So here's the dv. Is that positive or negative going downwards? Negative. But I went right. What's that? Positive. So this one is a negative divided by a positive, which gives me what? A negative slope. Is everybody cool with that? Yeah? All right. Now we get to the 2 weird ones. Because every diagonal line is either positive or negative in slope. But these guys aren't diagonal, are they? What's this guy? E to F. I do the up and down first. Did I go up or down? Does it matter? If I go this way from E to F, it's negative, isn't it? How far did I go side to side? 0. What happens if I try to divide by 0? No, you don't get 0. You get an error because it's infinity, isn't it? I like to think of this way. If I was a skier, I'll be a snowboarder, and I was going down a slope, Could I snowboard that? What would that be? Fall. It is not a slope. It is death. Because that is infinite. Everybody understand? Since that is an infinite slope, we call that undefined. Because there is no way we can explain the rise over run there, can we? It's not a slope. Now, what's happening in the last one? G to H. Is there any up and down? 0. Is there any across? Sure there is. It's positive. What happens if I divide 0 by anything? Then what do I get? No.
0.
I get 0. I have no pizza. Do you want half? Sure you do. Everybody wants pizza. Here's half a 0. How much pizza you got? Exactly. This is a 0 slope. Why? Imagine snowboarding on it. Does it work? No. You got to do this on your snowboard. And look like an idiot.
Or you need to drop your phone.
No, because you would never have... Oh, wait, you guys. Yes, of course you would have your phone while snowboarding. Because you would be selfieing. I'm going to be on Instagram. I'm going to get 1,000 followers.
Or you can just use Gmail.
Which is why snowboarding is lame. All right. So this is a 0 slope. Because you're not going anywhere. This way, you're falling to your death because it's infinite. This way, you're not moving anywhere. Right? Now, why have I got this big white space here? Because already I have given you 5 ways to find slope. One of them is m in that equation. Whatever number is there is slope. But it's also 4 other things. 1, it's the rise divided by the run. Rise, duh, up and down. Rise up, kids. You would stand.
No.
Uprising. That's 1. 2, it's the change in the dv divided by the change in the IV, which is wonderful if we're doing something in real life, like distance and time, right? It's also the change in Y, because if we're in math class, it's Y's and X's, over the change in what? Change in X. And it's also, if you need to find how far it is between 2 numbers in math, you are trying to find the difference between those numbers, correct? What mathematical operation finds us the difference? Subtraction. So it's also y minus y over x minus x. Except that makes no sense written that way, does it? Because if we do y minus y, what do we get? 0. So we have to add something to this. We add the following. y2 minus y1. Because sometimes we're given coordinates. So what then obviously must this one down here be? x2 minus x1. Everybody cool? Now in physics class, you're going to learn this and this. But your physics teacher is going to write it differently. He or she is going to write delta y over delta x. That's a Greek letter that means change. Physicists have chosen the Greek letter delta to mean change. So your physics teachers are going to have things like change in velocity divided by change in time. Yeah, delta t, delta v. You've seen it already if you've done your physics in grade 10. That's all delta is. It's just a Greek letter. Just like we already use theta. Right? Pi. Right? Alpha, beta, gamma. We use all of them in science as well for describing radiation. Everybody cool? All right. Now, let's apply this knowledge. Here is a graph. I am going to use 4 different colors to graph 4 different lines. You all are going to pay attention to how we do the first one in black, and then you're gonna do 3 on your own. Remember, we are dealing with this form. What do we know about this form? What is B? It's right in your notes from 2 seconds ago, guys. What's B? It was literally 2 seconds ago. What is it? The y-intercept. What is M? The slope, which is rise over run. Correct? Great. Which of those 2 options gives me a starting point on the graph? Is the y-intercept a place I can go on the graph, or is the slope a place I can go on the graph? The y-intercept is a place on the graph. The slope is directions away from that place, yes? So where am I going to put my first black dot on this graph? At the y-intercept, which in A is what spot? -4. 1, 2, 3, 4, and there I'm going to put a black dot. Now, I can't have a line with only 1 dot, can I? It's not a line. I got to have some dots to connect, right? Do I have a set of instructions for how to move away from this black dot? Yes, it's the slope. What is my slope? Rise over run. Since my slope in black equals 2, what's 2 really? How should we really write 2 if we were being totally technical? 2 over 1, which looks a lot like rise over run, doesn't it?
Whoa.
How do I rise +2 from here? I go up 1, 2. How do I run +1? I go 1 to the right. There's my next dot. How long will that pattern continue? To infinity. So could I go up 2 and right 1 again?
Yes.
And then up 2 and right 1 again? And then up 2 and right 1 again?
Yes.
And then up 2 and right 1 again?
Yes.
What if I was going the other way? Could I go down 2 and left 1?
Yes.
Could I go down 2 and left 1?
Yes.
Could I go down 2 and left 1?
Yes.
Yes, and then I'd stop because I was off the graph. What would I do with those myriad of dots? Connect them. Well, don't connect 4. You need to connect them all. Does everyone understand? Good. Now draw 3 more lines because you know how to do it. D might be tricky. I am going to continue to record but turn off the screen. So if you watch this later, you can see my process. Sure.
Be safe. Enjoy your travels.
Has everybody attempted? No rush. This is what it should look like. We already did the black one. So the red one, positive 1 for a B, and my slope was negative 1. So down 1, right 1. Or up 1, left 1. Everybody cool with the red one? Yeah? The blue one, my B was 5, so I went up to 5. My slope was negative 1 over 3. Negative 1, there's my negative part, and then positive 3. Or I can go the other way. Positive, but then I needed a negative run. Does everybody get that one? D causes people trouble because they're like, Mr. Meyer, there's no y-intercept. I know. Do we have a number that represents nothing? What is it? I have no money in my hand. How much money do I have? Zero. So my y-intercept is 0. My slope is the number that's with x. Mr. Myers, there's no number with x. Yes, there is. The number that is always with x, but we don't write it. What is it? 1. So it's positive, so I go up 1, right 1. Can everybody graph lines? Everyone? All right. Now, stop for a second. And since this always happens with this unit, I always seem to need to give a couple of extra days with the last unit. There's some questions here that apply to last unit. F of 2. What color line am I using if I want to find stuff on the f function? It's the black line, right? So the f of 2. Where do I go on that black line for the f of 2? 2 on the x-axis, right there, correct?
Yes.
What's the y value there? 0. So what is the f of 2? 0. Everybody got it? Where do I go for the h function? What color line? The blue line. And I want the h of 3, is it not? Where do I go? You all just did it correctly. F of 2, you went to 2 on the x-axis. Well, now I want the h of 3, so where do I go? 3 on the x-axis, 1, 2, 3. And I look for the blue line. It's right there. What's that value? You guys just graphed this too, yet you're all looking up at mine. Wouldn't it be easier to look at the one that's only a foot from your face?
Yours is pretty colors.
It's right there, which is what? 4. What's different in C? What am I looking for? I'm looking for G, so I'm going to a different line. I'm on the x or the y-axis. I'm on the y-axis, aren't I? Because x is still unknown. So which color line is G?
Red.
The red line. And I need to go where y is what? 4. 1, 2, 3, 4. There. Now I got to find the red line. The G of x equals 4. So that's y equals 4. There it is. But that's not the line, is it? The line is way over here, and I'm looking for the x value. What is it? -3. The G of -3 equals 4. Everybody cool? Now you do the last one. I'm back to f, correct? Which is the black line we did at the beginning. I want the f of x is now negative 1. Is that an x or a y value? X is still blank. So this is y equals negative 1. So I go to negative 1 right here. And now I need to find the line. It's right here, correct? I need the x value for it. Right there. What is it? Halfway between 1 and 2. So the g of 1.5 equals negative 1. Is everybody good? All right, now listen. You've got a hair under 20 minutes left in class. You have a choice now. You can either A, review your Unit 5, because you're having a test on it Tuesday. I can print off more of the extra unit reviews, but some people took a bunch yesterday. If you don't want to take one, that's cool. You could do that. Your other option is to work on page 182 and 183. That is the work we just learned how to do. Hopefully you are already making a connection between last unit, when we did specific things like distance and time, to this unit, where we apply those concepts to everything, x and y. So if you choose to do 182 and 183, you are still helping yourself out with your test that's coming up on Tuesday. Does everyone understand? Okay? Is everybody cool?
Yes, sir.
All right, I want to make sure, do me a favor, and just look. You needn't write this down. Just look. Y equals 3x minus 4. Can you graph that? Where would you go to start? Negative 4 on the y-axis. 1, 2, 3, 4. How do you draw a slope of 3? 3 over? Rise over run. Up 1, 2, 3, right 1. Why didn't I go down 3? Could I have? I could have, because it fits on the graph. 1, 2, 3, left 1. And there's my line. Cool? Okay. Yep. Because it's 3 is really 3 over 1. Right? Everybody cool? Okay, what if I had this one? Y equaled 1/2 x plus 3 halves. I can't rise 1, go 2 from where? From 3 halves on the y-axis. Why is that a pain in the ass? Because this isn't in fractions, is it? Who's in charge of this graph?
You.
We are. So if I say that's 1 when I go up 2 spots, where's 3 halves? Right there, correct? Now, what if I go, can I now go up 1, right 2? Up 1, right 2 is positive, correct? Down 1, left 2 is still positive, correct? There's my line. Is everybody good? Okay. What if I gave you this one? Y equaled negative 2/3 x minus 5/3. Now what do you got to do? Does your concept change? Do I still know the y-intercept, the x-intercept, or the slope? All I got to do is put my y-intercept on. Where does it go? I got to go by 3s now. 1, 2, 3. There's 1. 1, 2, 3. There's 2. 5/3. 1, 2, 3, 4, 5/3. Right? And now minus 2/3. I can go down 2. There's my minus. So where do I go from there? Right 3. If I go up 2, where's my that's positive. Where's my negative? Left 3. And I make the line. Is everybody good? All right. Now the last thing you need to be able to understand about this is this. I'm going to draw 2 lines. You're going to find me the slope. What's that slope? Would it help if I zoomed in? What is that slope?
Up
1.
over 3.
Positive or negative here?
Positive.
What about here? Negative. So what's the slope? No. Rise over run. 5 over negative 3.
But for that fraction, could you put the negative like?
You could put the negative in either spot.
Oh yeah, or you can just.
It could be negative 5 over 3, and it could be negative 5/3. Everybody cool? Okay. Wait. 1, 5. Uh-oh. I know you're confused. That's why I did it. Think about it. What has changed? Rise over run or the scale? Scale. I still have a rise and run, don't I? How far up did I go? 5. I went, each one of these is worth 1, so I went up 5, right? How far did I go that way? I went 3 squares, but how far did I go? What's each square worth on the x-axis? I went 3 quarters. Yes, you do. 1, 2, 3, 4. So each square is worth a quarter, right? So what is this? Which is 0.75. Is it positive or negative? Negative. So this slope is negative 5 over 0.75. Everybody with me? If you change the scales, you can no longer just count squares. You have to think of value. Everybody cool? But what if you change the squares to the same scale? Then can you go back to counting squares? What if I told you 1, 2, 3, 4, this was 1, and this was 1? Now, can I just count squares? Let's check. What is 5 divided by 0.75? It's okay. We'll just use our calculator. 5 divided by 0.75. 6 2/3. Everyone agree?
Yes.
Does everyone agree?
Yes.
So when I had different scales, I had to do that, correct? Now, when I have the same scale, how far up did I go? 5. I went up 5. And how far that way did I go? 3. What is 5 divided by 3? 5 divided by 3. 1.6667. Right? They're not the same number, are they? Okay. Everybody cool?
Yes.
When they're the same slope, when they're the same scale, right? You can count squares. When they're different scales, you have to count value. That's the point I'm trying to make. Everybody cool?
Yes.
Now you're done. You can now work on either 182 and 183 or your review. Okay? Go.